Hi everyone, welcome to the YouTube channel of SVSU Math and Physics Tutoring Center. This is Ajay, and today in this video we'll learn how to find the least common denominator of two or more rational expressions. Before we jump into the actual problem solving, someone might ask, what's the significance or purpose of finding the least common denominator of rational expressions? Like, why would someone look for it? Well, the answer is whenever we add or subtract rational expressions, we are required to first find the least common denominator of those expressions. So it has got a huge importance in algebraic operations. Now, let's go to problem number one. Here we have two algebraic expressions. So we'll first rewrite the denominators. So the first denominator is x squared plus 5x plus 4, and the second denominator would be x squared minus 1. So for the first denominator, now the second step would be to factor out these denominators. So for the first denominator, we'll first of all we'll write two x's in these two factors. So the product of x and x would be x squared. That's why we wrote 2x, one in each of these factors. Now here we have 4. So we need to break this down into two numbers such that the product of those two numbers is 4, and then they add up to 5, positive 5. So here we'll say, okay, so here we have 4, could be 4 and 1, right? So 4 times 1 would be 4, and 4 plus 1 add up to 5. So 4 and 1 are the perfect pair for these factors. So we'll go ahead and write, okay, plus 4 and then plus 1. Now for the second denominator we have x squared minus 1. So it's the difference of two squares. Here, as you could see, it could be written as x squared minus 1 squared. So for the difference of a square, we would simply, the square root of x squared would be x, and the square root of 1 or 1 squared would be simply 1. So the factors would be x plus 1 and x minus 1. Once we are done with factoring out the denominators, now we'd be looking for the factors that's common between these two denominators. So here we could say, okay, x plus 1 is common between these two denominators. So the least common denominator would be, first of all, the common factor. Now there's nothing common between these two denominators, so we'll just go ahead and rewrite the remaining factors as well. So we have the remaining factor is x plus 4 and x minus 1. So we'll say, okay, times x plus 4 and then x minus 1. Now since we have all of these factors included here as the product of common factor, as well as the remaining factors. So this is the least common denominator for the first problem. So this is how we find the least common denominator. Let's move on to the second problem. We'll apply the same procedure here as well. So first of all, we'll go ahead and rewrite the denominators. Here we have, since we have three rational expressions, we come up with three denominators. So the first one is m cubed minus m squared minus 6m. The second denominator is m squared minus 3m. The last one is m squared plus 2m. Now the second step would be to factor these denominators out. So the first step of factorization would be always to look for anything common among all the terms. So for the first denominator, we could see here we have m is common among all these three terms. So we'll go ahead and factor it out as m times. So once we factor out m, the remaining thing would be m squared minus m minus 6, right? Now we'll again be looking for anything that could be factored out. So here we have this m squared minus m minus 6. So let's see if it's possible to factorize this thing. So here we can say, okay, we have -6 for the last term, -6 here. So -6. We need to break this -6 down into two numbers such that those two numbers, the product of those two numbers would be -6, and those two numbers add up to -1 here, -1. So we could say, okay, the numbers could be -6, -6, and 1. Let's see. Here, -6 times 1 is -6, but -6 plus 1 would be -5. Here we just need -1. So that's not gonna work. Let's see if -3 times 2 works. Here, -3 times 2 would be -6, and when we add these two numbers, -3 plus 2 would be -1. So here, that's exactly what we need. So these two numbers, or this pair, works for the given expression here. So I'll just go ahead and get rid of this whole thing. Okay, so back to our factorization here, we'll say, okay, now we have m times our our pairs was -3 and then +2. Now for the second one, we have, first of all, let's find the common thing. As you could see here, m is common between these two terms. So we'll rewrite this as m times. Once we factor out m, we're left with m minus 3. And for the last one, here, as you could see in this one as well, we have m common between these two terms. So we'll go ahead and factor out m. Once we do that, we are left with m plus 2. So that's all we can do for factorization. So once we are done factoring out the denominators, we would be looking for the term that's common among all these three expressions, all these three denominators. So here, as you could see, m is common among all these three terms. So I'll just go ahead and say, okay, least common denominator would be equal to the common thing m. Let's see if there is anything common between two terms. Here we can see, okay, m minus 3 here is common between the first and the second term. So we'll say, okay, times m minus 3. We can also see that m plus 2 is common. M plus 2 is common between the second one, oh sorry, the first one and the last term, last denominator. So we'll go ahead and write those two common factors as just one of these. Now we don't have anything common remaining, or any term remaining among all these denominators. So our least common denominator would be the product of the common terms and the remaining terms. So the least common denominator here would be m times m minus 3 times m plus 2. So basically what we did is we rewrote the denominators of the given rational expressions, and then we factored those denominators out. We looked for the common factors among the denominators, and then we multiplied those common factors with the remaining factors. While looking for the common factors, we always looked for the factors having the largest number of repeats among the given denominators, or the largest number of repeats in the given factors of the denominators. And it could be, the largest number could be the number of the given factors, or maybe it could be common between some of the given denominators only. So we'd be looking for the common factors, and then we'd be multiplying those common factors with the remaining factors, and the whole product would be the least common denominator. Thank you for watching the video.